Hi everyone, welcome to workshop number 2 in the Polkadot Inc. Bootcamp. I'm just going to invite our speaker to the stage. I hope you're all looking forward to this workshop.
So welcome. So today the topic is Inc. and cross-contract calling with Inc. It's a bit of an intermediate series, but I think you'll enjoy it because I'm going to try to simplify it as much as possible. My name is Bruno. That's my Twitter handle, Bruno P. Galveo. Please follow and look forward to interacting with you on there. I'm a co-founder of Rogue. Rogue's a blockchain engineering company, specifically in Polkadot ecosystem. And we have another Twitter handle there, on pop.io, which is a suite of Polkadot products that we're building. So let's get started. The agenda today is we're going to discuss high-level definition of what a cross-contract call is. So you can think about what is it, and the mechanics. So there's actually in Inc, the Inc smart contract programming language, there's actually 3 different ways of doing it. And we're going to look through each one. And at the end, I'm hoping that you pick which one's your favorite. There's pros and cons to each one. And then as we cover these slides of the different approaches, number 3, I'll do a walkthrough of the code in the VS Code and actually deploy some contracts for you to see the interaction. And then finally Q&A. So if you think cross-contract calling, it's the definition loosely, it's the ability for one Inc smart contract to call another contract on the same chain. Specifically here, we're calling Inc messages. So another contract's Inc message or an Inc constructor. So we could do a cross-contract call to call the constructor, instantiate the contract, and then we can do another cross-contract call to actually call a function, a message on the Inc contract. There's 3 different ways of doing it in Inc. The first one is the reference based, so you have a reference to the contract. The second one is the builder based, where you're constructing the call. And the third one is my favorite, it's the trait based. And we're going to look at all 3. The trait based is more of like Inc. When you're writing Inc, you're writing in Rust, right? Inc is just like Rust with macros, extensions that help you write smart contracts. So it's like a programming language that's like Rust with ergonomics for writing smart contracts. And the third approach, the trait-based, it's a Rust way of doing cross-contract calling because Inc is piggybacking off of traits on that one. So that'll be an interesting one for us to see. So as far as the reference-based cross-contract calling, contract references refer to structs that are generated by the Inc code generation for the purposes of cross-contract calls. They give developers a type-safe way of interacting with a contract. So the idea is that you're going to import the contract that you want to call so that you can interact with it in a type-safe way. So the steps involved, if you look at that line of code there, we would insert that line of code in the contract that we want to call. For the example here, the name of that contract is other_contract. In the librs of that file, we're going to put this line of code that re-exports the contract reference. It re-exports itself so that on the contract that is doing the call, that will be calling other contract, in the cargo.toml file of that, we need to include other contract as a dependency. You can see there, that's other_contract. You're including it as a dependency. You're inserting the path where it's located. So you need that contract. You need other contract. You need the contract that you're going to be calling. You need that contract as a dependency in your cargo.toml. All right, so we'll look at the code later. And the third step, once the contract that can do the cross-contract call, that will call other contract, once it has included other contract as a dependency, we can then use a reference to other contract within the calling contract. So very simply, like you can see, like right here, we're importing other contract. We can do that because it's in our cargo.toml file. And we're importing specifically the reference to other contract. And then in this code here, we're storing the reference of other contract as other contract in our Inc storage for that contract. if you can think like, why are we doing this? Well, later, the next slide, I believe, we're going to use this other contract reference to call it. Now that we have a reference to it, we can call it. So before we call it, we have to instantiate it. And you can see in this slide here, it's a constructor, in constructor. We're passing in the other contract code hash. So that means that in order to instantiate the contract, other contract has to already be uploaded onto the chain. It has to already exist on the chain. Once it's on the chain, we can take its code hash. And you can see there, let other contract. We're specifying the reference. We're using other contract's reference because we imported that, we have that. And then we say .code hash, pass in the code hash of the contract that's on the chain. So one reason that, like the main reason we have the reference is because then we know how to interact with that specific code, that specific contract that we're specifying the code hash. And in this case, we're instantiating it. Okay. And we're returning the other contract reference. Other contract reference, we store that in state. We store that in the storage. And then finally, so the contract has been instantiated, we can now call its methods, right? And actually calling methods, it's very simple because in our Inc storage, we have the reference to the contract now. So we can simply say self.othercontract.flip or self.othercontract.whatever method is on that contract. So it's right there, boom, cross-contract calling. Okay, so that's using references. So the trade-off here with reference-based cross-contract calling, like a downside you could say, is that you need to include the contract that you want to call as a dependency. If you don't want to do that, there is another approach. If you want to call a method on a contract that's already on chain and you don't want to include it as a dependency, then you can use the call builder. So call builder is part of the builder approach. Let's take a look at that. So the builder-based approach, there's create builder and there's call builder. They offer low-level flexible interfaces for performing cross-contract calls. So as far as create builder, what create builder does, it allows you to instantiate a contract. And the reason it's builder, it's because you can build up that instantiation. We're going to see the code, but note that that contract still has to be previously uploaded. It has to be on the chain, right? It has to be already on the chain so that we can use create builder to instantiate it. And you can see this code here. There's the build_create. We're using the other contract's contract reference there. And we're taking in the code hash of the contract that we want to call. So that code hash, it has to be a code hash of a contract that's already on the blockchain, right? We pass it in there. And then specifically in the execution input, you can see that we're building there. What we're building there is we're going to instantiate the contract. So we're going to call the constructor of the contract using the Inc selector _bytes macro. And if that constructor accepts arguments, you can pass in arguments. So you can see we're building up that call there. We're building up the instantiation. And that's what the create builder allows us to do. And it returns the reference to the contract. Okay, so that's something that's available for you. Whereas the call builder will allow you to call messages on an already instantiated contract. And it's a builder, so same thing, you get to build up the call. You can see there's the code. But what's cool about this is that there's no reference there. So we don't need to include a reference as a dependency. So that's pretty cool. All we have to do there is include the account ID of a contract that's on chain. And then we specify the selector, whichever message we want to call on the contract. We can include arguments. So we build that call and we execute it. So that's a pretty cool method if you want to do cross-contract calls against any Inc smart contract on chain. And then finally, my favorite way is the trait-based approach. With a trait-based approach of cross-contract calling, the calling contract imports the trait that the other contract adheres to. the calling contract uses inc : contract ref macro to call the other contract that implements the imported traits. So it's based off of traits. So that's a lot of words. Let's look at some code. So on this slide, you see a trait, right? So here's a Rust trait. Like this is Rust code, right? So it's an ERC20 trait, and we're defining a function total supply, returns balance, another one transfer, and it returns a bool, right? So that's the trait. We have to implement that. So the idea is that this other contract, the contract that we want to call, it implements this trait, right? It defines what total supply does, how it works. It defines what transfer does, how it works. The other contract defines these traits, implements these traits. And we have a calling contract, the contract that wants to call that contract that's defining those traits. And in the calling contract, you can see there in the inc storage, we're storing with this contract ref macro, we're actually going to store a contract, a reference to a contract that implements that ERC20 trait. That's pretty cool. And in that constructor, you can see that when we're constructing, when we're instantiating a new contract with new, it's accepting actually a contract that implements that ERC20 trait. So it does the conversion. It'll convert from the contract's account ID. It'll convert it and store the reference to it. And you can see it'll return the reference, which will be stored in the storage. And then once it's there, we can simply say, hey, in the calling contract, we can say, okay, hey, I want to do a cross-contract call to the ERC20 contract that's implementing that trait. So self.erc20.total supply. Boom, cross-contract call. Not bad, right? Pretty cool. So let's talk about, I want to show you the actual code, and I'm going to drop down here in a VS Code and just do a walkthrough of some of this code so that it's a little bit more concrete. These concepts are a bit more concrete. So this here is some code. Hopefully you feel comfortable with this. But it's a contract called cross contract flipper. If we look at the cargo.toml, let's start there. So a few things that I want to point out here. Is this big enough for everybody? Do we need to make it a little bit larger? Let's see. Okay. Maybe that'll, okay. So we're importing the inc crate here. Okay, we have to do that. It's an inc smart contract. And this example, this code here is an example of using reference-based and builder-based. So for reference-based, like I said, we need to import the contract that we want to call. That's what we're doing in line 14 here. We're importing it, and we need to say features inc as dependency and the path. So it's literally /other contract. If we look at the navigation here, other contract right there. So within the smart contract, there's another contract embedded in here. And if we look, librs, there it is. It's called other contract. And if those of you who have worked with inc before, this is just essentially like Flipper. It has storage here. It has value. It's a Boolean, true or false. So value could be either true or false. It has a flip method, which when we call it, it'll just flip the value. If it's true, if the value is true, it'll be false. If it's false, it'll be true. And then we can read the value. Okay, so very basic. What I want to point out to you in this contract is that we're re-exporting the reference, right? So that's key there. We need to do that if we want to do reference-based contract calling. So that's about it for that contract, like pretty simple, pretty straightforward. If we hop back into the cross-contract flipper, so this is the contract that we want to call other contract, right? So we're importing the reference right there. We're importing the reference to other contract. And we have a storage, inc storage, that is actually going to accept the other contract reference. And I also have here, for example purposes, we'll also store the code hash. That can be useful depending on your use case. All right, so in order to set the storage up, we need to call the constructor. And you can see there's actually two constructors that I have here. One is the new constructor. It'll accept the code hash of other contract. So that means the contract has to be uploaded already on the chain. We're going to pass into the constructor as an argument the code hash, the address, right? Like, not the address, sorry, the code hash of where that contract, like the contract, the hash of the contract on chain, right? So that's the whole contract. We're passing in the hash there, right? And we're going to use the other contract's reference here, which is available because we imported it. And we're going to say .code hash, and we're going to instantiate it. So we're going to instantiate this contract here, right? The code hash, that's the contract, based on that reference, right? It's got the types. The reference has the types. So we're going to instantiate it. And when we instantiate it, it's going to return the storage, right? So it's going to return the reference, and it's going to return the code hash, which we're going to store inside of the state of the contract. All right, so pretty basic. The other way that we could do this is using the create builder approach. So the create builder approach, you can do the exact same thing. We're passing in the contract hash. We're using build create this time, along with the reference and the code hash. And we're calling the constructor new using execution input. And then we're returning the reference, which we return out of this message here. We're returning it and we're storing in state. So same thing, different approach. You can just build it up, right? Does the same thing. Okay, so you get to pick which one you want. So once the contract is instantiated, then we can call it. And this is calling it using the build call. So the call builder approach, right? And the call builder approach, what's cool here is that you don't see any reference here. However, we are using the reference here because we're saying self.get other contract account ID. So we're passing in an account ID. It just so happens that the account ID happens to be the contract that we have stored in reference. If we look at this method where it's defined, it's down here, get other contract account ID, you can see that it returns self.other contract that get account ID. So the account ID of other contract. So it's crazy because this is doing a cross-contract call in itself. If we look at other contract and librs, scroll down, I believe down here, yep, get account ID, right? So this is interesting. Like, it's going to return the account ID of that contract, which we're going to use. We're going to return it here, which we called up here in our builder, right? So here it's a mix of builder with reference-based. So we're using the builder approach to get the account ID. I'm sorry, we're using the reference-based to get the account ID. And then we're using the builder call approach to call that contract, specifically to instantiate it. Or I'm sorry, specifically to call the flip message on that contract, right? So this is actually like a combination of both approaches. Now, if we don't want to use references at all, we can do this call here, flip to. So it's using the build call, the call builder approach. And if you notice, we're not passing in a code hash, we're passing in an account ID of a contract, whichever contract that's on chain that we want to call, any contract that's on chain, you pick, right? However, that contract does need to have this message, the flip, right? Because that's what we're calling. So we're saying call that contract without account ID, no reference, and ink selector bytes call the flip method on that contract. All right, so that's pretty cool. We'll test this out. We'll deploy this contract. And then, of course, here's just the reference base of how to call that. This one here is calling the flip on a contract that we have the reference to, right? So that's the number one approach. This is number two, the builder call approach, right? So let's actually take a look at that. So let me first, let's let's deploy the contract. So we're going to use pop CLI here to deploy the contract. You can use pop-up contract, and we can say this contract here. When we instantiate it, we're going to upload it and instantiating it at the same time. But first, before we do that, because it depends on the reference, some of these methods depend on the reference here that we're importing. First, we have to actually upload the other contract. So let's do that. I'm going to create a separate terminal here for that. And I'm going to CD into other contract and upload that one. That one has a constructor, a new constructor, and it accepts an argument for like how you want to initialize the state of value, right? So I'll initialize it to true. So that's deployed. What I want to show here, let's make sure it's deployed. I'm going to grab the contract address and I'm going to show you a few tools that I use. So one tool that I use is this UI.useInc. So I like it because it's like a UI tool, and I'm going to add this new contract that is uploaded. I have the account address. There it is. I'm going to call it Flipper. I'm going to call it other contract. Let's stay consistent. And I'm going to include the metadata. So that's inside of contracts folder, cross contract Flipper, other contract, target, inc, other contract.contract. So that's the metadata. So the UI knows how to show it. And there it is, right? That's the contract. You can see it's got the methods that we went over: flip, get, set, and get account ID. So it's a nice way to see the contract. So we can even check, like if I say get to get the state, you can see that the state is true. So that's what we initialized it to with the constructor, to true. So it's true. So now that it's uploaded, it's on chain, we can now go back and deploy the cross contract flipper. So pop up contract. I don't think the constructor for that one, I don't think it needs oh yeah, it does need an argument. It needs the code hash of other contract. So we could pass that in. So let's to find the code hash. So let's grab the account ID of other contracts. So I have it here. Copy it. One way that we can get the code hash is by using Polkadot.js UI. So if I go to the contracts tab, or even one way to do it is go in the chain state, right? So we're in the blockchain here, and there's contracts palette, and there's different like methods here, right? One of them is contract info of, and we can pass in the contract, and that's the account ID of the other contract, the one that I just uploaded. And if I submit that, it gives me like the metadata of the contract. One being, I don't know if you can see that, one being code hash. So I'm going to copy that code hash of other contract and go back to the terminal. And you can see the argument here. So when we do new, it's expecting the code hash of other contract, and it'll instantiate it. So let's do this. Let's see. That's the code hash. That was pretty fast. So there's the account ID of cross contract flipper. Copy it, go back to the UI. I'd like to see it here because it's just nice. It's easy. So it's already on chain. We instantiated it. Pass in the account ID. I'll call it the same thing, cross contract flipper. Grab its metadata, so the UI knows how to display it. So it's in the target folder, inc, cross contract flipper.contract. Add the contract, boom, right there. Okay, so we're looking at the contract, right? We already saw the code. We can see that there's different methods here, right? So like I could call get. The other way that you can call it is through the pop CLI tools. If we do pop call, if you're not sure, you can say .help, --help, and you can see, okay, there's pop call command. So pop call contract, -- help if you want to see all the options available. And there's an execute. So if you want to submit an extrinsic, so we're going to need that. You can pass in the account that's going to be doing the calling. The default is Alice. That's why when I instantiated the contract, I didn't need to specify Alice. You can specify the URL of the blockchain that you're connecting to that has the contracts palette. The default is 9944. That's already running on my machine. Pop CLI will also, by the way, when you deploy a contract, it'll automatically instantiate a substrate contracts node in the background for you to test your contracts. So that's why this is already running on my machine. And then the other one is the contract. So that we're going to need, specify the contract address and the message that we want to call. All right, so let's construct that. So if I do pop contract, pop call contract, contract, -- contract, which contract do we want to call? I want to call other contract. I'm going to copy the address, copied. Let me make this a little bit higher. Paste it in there. Specifically, I want to call the message here of other contract. Let's call get, right? So let's see the value that's inside of the storage. So in order to call that, but remember, we're calling cross contract flipper. I'm sorry. We got to call, otherwise it wouldn't be a cross contract. So let's grab the cross contract call flipper account. Otherwise that would be really boring. So let me reverse here because we're going to do a cross contract call, right? So cross contract call. So that's cross contract call flipper account address -- message. And what I want to call is call set. Okay, so that we're going to call this, it should return the value of other contract. Okay, so paste that method in there and we're going to say -- execute and hit return. And boom, there it is. So it fired off. Okay, so that's cool. Calling the contract. There's the events that fired off. You can see that's balances palette event, contracts palette event. And then finally down here, call completed. All right, so we can see here that the call executed. So in order to see that actually in the UI, I can show you. If I say call get, same thing. And I say call the contract with Alice. And you can see down here, it called it. And it got a result back and it's true. So the state of other contract, the value is true. Okay. And just to show you that this fired off on the blockchain, you can go back into the Polkadot.js, go into the Explore tab, and you can see there it is. These are the recent events, right? So it's there also for debugging purposes. You can look at all the events. So let's call flip. So we're going to call flip on other contract using this one. So let's call it using build call flip one. Okay, so if you remember build call flip one, it's based off of the reference here. Okay, so it's going to grab the account ID of other contract that's uploaded on chain, and it's going to call flip. So the result should be false, right? I'm going to call it. So let's see what it is now. We're going to check the state of other contract, call get, and you can see it's false. Okay, so we were able to do a cross contract call and change the state of other contract. So that's pretty cool. The other way, so if I grab other contracts account ID, here it is, copy. And I use approach 2, right, based on account ID. So it's asking here, what's the account ID of other contract? Well, it's not Alice, it's actually, I have it copied in my clipboard. There it is. And I'm going to flip it. So I do a call contract and it's flipped. So now if I check the state, these are all cross contract calls and you get false. Okay. So the UI is actually smart enough. When it reads state, you'll notice, I don't know if you noticed, but it already gives you a preview. Because when you're reading state, technically, you don't need to do a transaction, submit a transaction. You can read it using the RPC server on the node. So each substrate node runs an RPC server. So whenever you're reading state, you can just use an RPC call. It doesn't have to be an actual transaction. You can also do it via transaction. That's what this UI is doing, but you can do it without a transaction. And you can use PopCLI to do the RPC call as well. So what I want to show you here though is like, what if like we pick a contract that like isn't like a dependency to cross-contract flipper, and we say build call, use the account ID of that. Does that work? Just to prove to you. I'm going to drop in my terminal here. I'm going to create a new contract, a flipper contract. So there it is. I'll call it flipper. Okay, CD into flipper. And I'm going to upload flipper default to true. So it's going to build it because it hasn't been built in release mode yet. And once it's built, then it's going to upload it and instantiate it. So it's going to take a minute. So while it does that, I also want to show you that in the Polkadot.js, there's a contracts tab. Notice how there's nothing here. And I don't have any contracts on the blockchain. That's not true. Your contracts are actually there. If you wanted to check, just go into the chain state, contracts, and then you can say contract here, disable this and just submit. These are all the contracts that exist right now in the node. Okay, so they're there. If I were to copy one of these, let's do it this way. I'm going to go back to the contracts tab. And I'm going to add one using add an existing contract. So I need a contract address. So I'm going to go here. Let's say cross contract flipper. There's the address, copy it, paste it in here. So it's just another way of seeing things, right? Just want to show you the different available ways. You still need the ABI in order for it to, the UI to know how to display the metadata. And so there it is, save. And now it appears here, you can see the different messages. Okay, so you get to pick like what you want, which one you want to use, this one or that one. I tend to use a combination. So let's go back here. Okay, the account, your contract already exists. A contract with the same account ID already exists. So won't be able to show you that one because it already exists. I can't remember which one it is because I uploaded contracts before. Technically, we could use a salt to upload the same contract, and so that the code hash is different. But you can use build call flip to, right, to call any contract that supports that method. So you can try that. I would like to try it though. Do we have time? Because I also want to go over the trait-based stuff. Let's give it one shot. So I believe I had this one here. I believe there's a salt argument here. Yeah, dash salt. Let's try to do that. So I wonder, can I say Bruno? Let's try that. Oh, it needs to be a hex. Okay. No, odd number. Okay, so let's grab a hex. I'll grab a hex that's on chain. Let's see. So go here, contracts. I don't know, just grab some random contract. Oh, there's a hex here. Let's try that. Some random hex, right? Okay, deployed. All right, that worked. Okay. So I got a Flipper account address here, right? That's the account ID of Flipper. And if you wanted to, like I said, you can just add the existing contract here. Boom, Flipper. And then I need to dive into the metadata here, grab the metadata. And there it is. Okay, it's on chain, right? Let's call this. Build call flip to accepts account ID. going to drop the account ID of Flipper that we just uploaded and instantiated. So just to confirm here, actually, I'm going to read the state of Flipper right now before we execute the call, the cross-contract call. So it's true, right? Which makes sense because that's what I instantiated to. So if I do this call here, this cross-contract call, it'll flip, right? All right, let's call it, boom, done. Let's check the state. It's now false, okay? There you go. All right, so that's there for you. So we covered reference-based, we covered the builder approach, and there's a different trade-offs. So now let's look at the trait stuff. So I have a different code base here. This is, make it larger. So what we have here, let's make it real simple, right? So we have a contract, librs, and this contract is called caller because it's going to be the contract that's going to call the other contract. It's going to call a contract that implements a specific trait. Where is that trait? So you can see that there's a traits folder. Make it larger. The traits folder is independent of the contracts, right? If I open traits, it's actually, there it is. It has its own cargo.toml file, librs, and it's a trait, increment. It's called increment. It has the interface. It has two functions, inc, which is increment, right? It's going to do the incrementing a counter. And it has get to get the state of that counter, right? So whoever implements this trait is going to define the behavior, right? But notice it's its own crate. So what's cool is that if we look at the librs caller contract, the cargo.toml file, we actually see that we're importing that trait as a crate, right? There it is, /traits. Okay. And so that it's available so that we can access it in here. And there's also a contract within this folder. There's a contracts folder and a contract called incrementer. There it is. And in its cargo.toml file, you're going to see that we're importing that trait as well, right? So we're importing the Rust trait. And in that incrementer, we're importing it here, we're using it, right? There's a trait. And we have a storage where we're storing the value. And similar to flip, this one's a little slightly different, right? This one is actually, you can store a value and increment it. So the constructor initializes to the value to 0. And then we can say it has a unique function here called increment by, where we can actually set a number, a value, say like increment by 30, right? That has nothing to do with the trait. And then finally here, we're implementing a trait. You can see implement increment for incrementer contract. And we're defining the behavior, right? So for inc, we're saying increment by 1. Pretty cool. For get, we're just simply returning the state. Okay, so that's the incrementer contract. We're going to do a cross-contract call from the caller contract to call these methods using trait-based approach. So how does that work? So we have the caller contract. We're importing the trait. And then inside of our storage, something interesting happens here. We're using the inc : contract ref macro. And basically, this is saying, hey, we accept any contract that implements this trait, the increment trait. So any contract that implements that trait, we're going to store in the storage so that we can use it. So in our constructor here, you can see a little bit more of it. Like we're accepting an account ID of a contract. And it's going to say incrementer.into, right? And all of a sudden, we're going to have it inside of our state. We can then go and we can say, we can do the cross-contract call. So we say self.incrementer.inc, because we have a reference to it dynamically. And we can call the methods on it. Okay? Same thing with the get, self.incrementer.get. This is probably the recommended approach for cross-contract calling. When you work on your cross-contract calling applications, this is the newest approach in Inc. Okay, you could say. And I like it because it's the Rust way of doing things. It's very aligned with Rust and traits. All right, so we got about a few more minutes. I want to show you the resources available, right? So we covered a lot of code. And by the way, this is the same thing. You upload the incrementer contract, and then you upload the caller contract, and then you call the methods, right? So this is a good exercise for you. I'll give you the repo of this, and you can test it just like I did, all right? And it'll work nicely. So as far as resources, what I covered today, you can see in the slide deck, I had the links, and up here is the link as well. I'm happy to share the links as well. You can see that today we covered how to use the call, the cross-contract call builder, the create builder. So these are available, like the definitions of these are available in the Inc. Rust docs. You can read a bit more about them. You can play around with the code that I showed you. And there's the build call as well. Okay, so the documentation is there if you want to read more about it, as well as for the contract ref. There's also an example here. And then we also have the Inc. documentation, right? So there's a section in the use.inc website that has cross-contract calling. You can read a little bit about it there as well. Okay. And then as far as the POP CLI stuff, there's the POP documentation website, learn.onpop.io, which has a section deploying your contracts locally. So if you want to use POP CLI, there's a guide there how to use it to deploy contracts locally. So you can play around with that as well. And Inc. also has an Inc. examples repo, which has several contracts in there. One of them being a cross-contract call contract, and the different ways you can do it, including some, I would say, like deprecated ways. I recommend actually you use the code base that I showed you, which that one is under my account here. It's called cross-contract flipper. That's the code that I showed you today, uploaded and instantiated and such. But this also has the V2 stuff, the new stuff that I showed you. Okay, so that's there as well. There's also a more basic one. So if you want to look at that code, it's just like a very basic using reference approach. Okay, and then lastly, this is a trait one, right? This is the more advanced one. That's the code that I just showed you in red. And that's there as well. So if it's handy there, just clone the repo and just like CD into it, build it, deploy it, play around with it. Okay. That's it as far as everything that I wanted to show you. If you're interested, like we're improving POP CLI. So if you've been using it during your time here and you have some feedback, please join our Telegram channel on pop.io and give us feedback, and also like Inc. related stuff, right? So we're working very closely with the Inc. programming language. So we'd love to hear your feedback, especially with this presentation, cross-contract calls. Even if you come up with some code, right? If you end up building some code for cross-contract calling, please share it in that channel. I'd love to see it. We also have a Twitter. Please join on pop.io. And that's it. Yeah. Oh, and we have a network that we have a test network, Pop network, that you can deploy Inc. smart contracts to. So if you want to go and test that out, that's also available on pop.io website. Yeah. So now I'll open up to questions. Looks like we have some questions.
Great stuff. Yeah, we have some questions in the question tab. Got about 5, I think, and then there's one in the chat as well. Do you want, are you able to see the screen? Because I can put them up on the screen if you want.
I can see the questions. Okay, I see the questions. Maybe we start with the questions in the questions tab. Okay. It looks like it really depends. Well, can I drag this here? Okay, you have it. It looks like it really depends on the situation you're calling the other contract. Yeah, I would say the trade-offs, yes, it does. Okay. The other question is there an industry standard for cross-contract calling? Which style do protocols use more often? That's a great question. Inc has been progressing. Inc has been seeing how developers use its language, and it's been improving iteratively. In fact, I don't know if you've been keeping up with Polkadot governance, but there's an, I can show you actually, it's actually pretty cool because I think it's Web3. Inc v5 just came out, Inc version 5, right? And it has new features. And you can see that there's a proposal that's 75% yes, and it's to audit version 5 of Inc, right? So that's pretty cool. So v5 is already available in the docs. So I'd recommend you, when you're working with Inc, use the v5 features and build v5 contracts, right? The recommended approach, I'd say, if I had to pick out of the three, would be the trait-based. Other question. Is it possible to call Solidity contract from Inc smart contract and vice versa? If yes, how do we do it? Oh, that's a great question. So it is possible to call from an Inc smart contract, do a cross contract call to a Solidity contract that uses Solang. You can see there's actually in the documentation for cross contract calls, I believe it's down here somewhere, but not vice versa. Okay. Here it is. Let me make it larger. The call builder requires only a contract's account ID and message selector. We can call Solidity contracts compiled using the Solang compiler and deployed to a chain that supports pallet contracts. See here an example. However, the reverse, calls from Solidity to Inc are not supported currently by Solang, but there are plans to implement it in the future. So that's the current state of things. Yeah. Great question. May call one contract from another blockchain. That would be like, that's actually, there's a presentation. I hope that it gets delivered. I think it's coming, where it's XCM calls, right? You could say it's like cross-chain contract calls. This is cross-contract calls. There's another way called cross-chain contract calls, which is, yeah, really cool. That has, and that's the beauty of Polkadot, right? That's one of the main reasons we build on Polkadot, because there's these sharded app chains, right? These parachains that can communicate with each other, right? And if there's one chain that has pallet contracts and another chain that also has pallet contracts, or even has some other methods, you can use the XCM language within Inc. Inc v5 supports XCM. So you can do a cross-chain contract call. Yes, that's beyond the scope of this presentation though.
That is in our next workshop next Tuesday, is cross-chain contract calls. So,
so practice with this one before that one. I think you said that Inc is basically Rust with added macros. Is that true? Are there any other significant differences? Yeah, there are other differences. Like one of them is, so I don't know if you know the background and the history, but Dr. Gavin Wood, he was a co-founder of Ethereum and CTO there, and he also created the Solidity programming language. And he had these ideas that he wanted to pioneer, and that's where he went and he created Polkadot. And with that, he wanted to create a better smart contract programming language that was more embedded into the blockchain, into Polkadot. And there was a team within Parity that was involved in that. And they looked at a lot of the trade-offs between Inc and Solidity. And you can see here on the documentation website, it lists some of the differences. And they try to build, or they did build, it's actually at a mature state right now, an amazing smart contract programming language that enables you to write contracts that are, how do you say, more, it's built with Polkadot in mind, right? So if you think of the substrate contracts node, right, this node here, right, it's a blockchain, it's running, and you have specifically in there a module called contracts, right? It's a palette, we call it a palette and substrate. It's inside the Polkadot SDK. It has all this Rust code to be able to run our contracts, right? Upload them and instantiate them and call them and all these beautiful things. And Ink was written with substrate in mind. So there's a lot of things within Ink that are like part of Polkadot, or like they hold each other's hand, right? So if you're into developing in Polkadot, I'd really recommend developing Ink smart contracts. And it's also like an investment, I would say, because from my own personal experience, when you start getting deep into the Ink smart contracts, there are times that you have to debug stuff. And sometimes you have to actually drop to a lower level stack, lower than Ink, into the actual like palette contracts code base to look at errors and certain things. So because you're already invested in Rust, it's actually not that bad to drop into the substrate level, into the Polkadot SDK level, and read the code and try to understand errors and how things work. So if you weren't doing it in Ink, you were doing a different programming language, there would be a slight difficulty there. Another question, how to call any contract with any arguments in a general implementation? Like using the low level call, address call. So for Solidity. So for that, like for low level calling, like going back here to the palette contracts, like more low level than Ink, you'd have to use the palette itself. So if you go into the extrinsics and you go to the palette contracts, there's the call, right? So contracts, so Ink, the lowest level like you can get, Ink is at the end of the day, it's calling contracts.call. And then for Solidity stuff, you'd have to look at the substrate Solang stuff. Like specifically, it's not substrate Solang, it's just Solang, the Solang compiler. And at the end of the day, Ink smart contracts get compiled down to WASM. And as long as the WASM adheres to the API of palette contracts, it works. And so as far as my understanding with Solang, because I haven't worked with Solang, it's in a similar approach. It'll compile down to WASM, and the WASM can adhere to the same API that palette contracts needs, right? And vice versa. So I did want to show you something in relation to that, actually. At the top of this code base here, some of you, this is the first time you've been interacting with Ink, right? This is your Ink journey. And you'll see this stuff in Substrate and Polkadot SDK. You also see it in Ink smart contracts. I don't know if you guys know what this is, right? So this line of code, it's documented here. I wrote some stuff here. So typically when you compile an Ink smart contract for production, it compiles down to WASM, not the native target, right? A WASM target. WASM is really compact. It's really small WebAssembly, right? And it's really efficient. And that's one of the trade-offs with Ink, was that in other smart contract programming languages is that it's small because it's WASM, and it's really performant because it's WASM. However, like when you run your Ink end-to-end tests, I don't know if I have any end-to-end tests here. I don't have any defined, but it's here. If I were to define some end-to-end tests, then when you compile this, it actually compiles and it outputs the native target. And Ink itself, I believe it says here, where is it? The Ink crate we import as a dependency provides necessary functionality in place for the standard library. So when you're compiling no STD mode, Ink has some stuff inside of its crate that replaces what the STD standard library has in terms of Ink functionality. So that's where we get a little bit of performance boost there. So I hope that kind of answers your question. Another question?
So someone has asked, how can they contact you?
So I'm in the Pop Telegram channel, like the on Pop.io. You can drop a message in that channel. Like we're a team. I belong to team co-founder of Rogue.io, and we're always looking for feedback. I'm also on Twitter. You can interact with me on there. Probably Telegram is the easiest one. Yeah.
Nice. Cool. Someone sent your Twitter earlier in the chat, so that's there as well. In terms of other questions, there are a couple of people typing, but I'm not sure if they're questions. Very quickly, because we have come to the end of the session, if you have any last minute questions, put them in the chat. But I wanted to make a quick note about homework for people who want to graduate and get a certificate. Basically, the idea is we want you to implement what you've been learning. So for this workshop, there's some very easy homework. You use one of the 3 methods, you look into it, you implement it yourself, and you look at the pros and cons, and then just write a little post about it in the Discord so that we know that you're consolidating your learning. But Bruno, if there's any, can you think of any other sort of little tasks people could do to maybe for a beginner?
Oh boy, I actually do. So in this, like the fact that I said there's no end-to-end tests here, what you could do is a great way to test the code and learn the code is by writing tests, right? So you could try to write some end-to-end tests for this code base. You're welcome to create a PR. If it looks good, I'll even include it in the repo. The other one that I have, it's maybe a little bit more advanced, but in the librs, at the very bottom, there's a bonus exercise here. I've already covered the reference base, the builder base, and the trait based. There's another one. It's out there on the fringe. It's called delegate calls. So you could try that as a bonus exercise, try to implement this. And yeah, that would be a good challenge, but I'd say that's a bit more advanced. I have the links here to the actual API if you want to take a look at it.
Okay, very nice. So we'll be sending all these links in the chat. I'll get any relevant links off Bruno. I'm not sure how many of them are in the chat. I don't think any are. And I'll forward them on to you guys, so don't worry about that. In terms of people who missed the first session because they've signed up for the bootcamp late, don't worry about that. If you watch the recording, which is on the Encode Club YouTube channel, and then you make a post about your learning, then we'll excuse the absence for the first workshop, given that you've joined late. But other than that, you're required to attend bootcamp workshops live in order to graduate and receive a certificate. But that's just if you want the certificate. Otherwise, you're welcome to watch them asynchronous, as I'm sure a lot of you will be rewatching anyway to consolidate your learning. So I don't think we have any extra questions. Where can I get the recordings? On YouTube. Also, if you're in the Discord channel, I'll be posting the links so you won't miss them there. Yeah, thank you very much, Bruno, for this workshop. It's been really, really interesting and great for beginners and experienced people alike. Lots of things to try. Thank you everyone for joining us for workshop 2. As Bruno said, we have cross-chain XC workshop next week, next Tuesday, by your co-founder, I believe.
Yeah, Peter.
Peter, Bruno's co-founder, will be teaching that one. So we'll see you all on Tuesday for that workshop. Thank you everyone for joining us and have a good rest of your day.
Thank you. Bye.